Welcome to episode 29 of Ask the Grounding Experts, where our experts from E&S Grounding Solutions answer your engineering questions about the world of grounding and earthing. Today, we bring you part 5 of a 5-part series answering the question, what are the 4 lightning scenarios that cause problems? Let's wrap this series up. Here's David.
All right, everybody, welcome to part 5 of our 5-part series on the 4 lightning scenarios and how to resolve them. I know many of you have been waiting for this final resolution, and I know we're trying to get these podcasts out as quickly as we can, but please forgive us. It does take time. Our producer, Steve, thinks we're a little evil for waiting so long to finally tell you guys the resolutions of all this. But anyhow, here we go. So just a brief summary. If you recall, we had 4 major scenarios of a lightning strike. One of them is an air-to-air strike, cloud to cloud, causes massive electromagnetic fields. They form easily down in your building and causing damage. That's the number one most likely thing to cause damage to you. The second most likely scenario would be a nearby ground strike. Lightning hits the earth. Those electrons, it's like dropping a pebble into water. Those electrons travel across in a wave or a ripple across the surface of the earth, hitting your building, causing all kinds of damage. The third most likely is the lightning strike hits the incoming power lines. There's hundreds of kilometers of these power lines. It's highly likely they'll hit them, and then those lines are just nice copper conductors straight down to your building. Again, they're just trying to find a path to ground. You've got grounding at your structure, comes right in, causing all kinds of damage. The fourth scenario and least likely scenario is a direct strike where it actually hits your building directly. Very unlikely for most cases. Other areas of the country a little higher than some areas. Varies on where you live. But bottom line is most damage isn't coming from a direct hit. But if you do get a direct hit, usually lots of damage. Even when you have a good lightning system, it's just a lot less. Something like if you have a lightning protection system on your building and you get a direct hit, the estimates are something like 99% less damage will occur if you have a good lightning protection system. You only suffer 1% of the damage of an equivalent building that doesn't have a lightning protection system. So those are the 4 scenarios. So how do we resolve those 4 scenarios with our lightning protection systems and grounding systems? So really we have 3 components that we're going to utilize to resolve 4 problems. So the first component is this overhead Franklin-style lightning protection system. This is basically, you can imagine a copper Faraday cage that we're going to put over the top of our building. If you don't know what that is, imagine just a copper mesh, a net, if you would. We lift it up, we put it right over the top of our building, and then we tie it to ground. That copper mesh is going to protect us from a lot of different issues. A quick side note, if early streamer emission systems are not part of the NFPA 780 or the IEC, they're actually banned. You should not be using those. There's big problems with them. There's no evidence that they work, and we would highly recommend you make sure you stay with Franklin-style systems and do not use early streamer emission systems in any way, shape, or form. So that said, that Franklin-style system is our first protective mechanism, but that Franklin system has to get tied to ground. If it's just floating in the air, it's of no good to us in many ways. It needs to have a connection to the earth, and that's where our grounding systems come into play. Generally speaking, we have one of 2 systems. One is the down conductors from the lightning protection system go straight into a simple ground rod, or they go into a loop. We like the loops, and this is our second component, which is grounding systems. And the reason we like the loops is if you can imagine as the crow flies, you're looking down onto a building. Let's say it's just a perfectly square building, 100 by 100, with 4 down conductors that come down from it. So on the roof, you've got a loop with aerials on it, and there's 4 wires that come down from the roof and go straight down, and they're tied to a ground rod at the bottom. If we were to measure ground rod 1 and it was at 20 ohms, and ground rod 2 was at 15, and ground rod 3 was at 10, and ground rod 4 was at 5, you would see that if lightning hits the top of our building, we're going to have a difference in potential immediately. Most of the current's going to want to try to flow down that 5 ohm ground rod versus the 20 ohm ground rod, and so on. So we're actually generating a difference in current flow instead of an even flow. We're generating a difference in potential, and that difference in potential can cause problems in the steel that's below it, causing current to flow. And again, we could still suffer damage because of that. So if we have a complete buried ground ring all the way below grade that ties those 4 ground rods together below grade, then there's no difference in potential between those ground rods. And when lightning hits, you'll get an even current flow. Meaning, so if 100,000 amps strike hits your building, 25,000 amps will go down each one of those down conductors evenly, and evenly around the structure, around the ground system, causing an even voltage rise across the entire building. That's our second component that we can utilize. The third component that we utilize in lightning protection systems is surge protection devices. And we see this now, and I believe it's Article 243. It's a brand new article within the National Electrical Code. If you're in the IEC, you've been requiring this since at least 2008, maybe even earlier. And what we're doing now is cascaded surge protection systems. So these systems, the type 1 we call it, is right at the incoming power line, power feed, and this will reduce the good rule of thumb for an incoming surge is something like 12,000 volts will come in. This will knock, the first surge protection device will knock it down to about 700 volts. And then you put a second one into the sub panels in there, and that one will knock it down again to, down to about 200 volts. And then you put it in your branch panels, and it will knock it down to about 20 volts. And then at your devices, so we have what they call a type 4. That could be the surge protector strip you're plugging your computers in. Those things will knock it down to usually below a single volt if it's cascaded properly. If you're only relying on that type 4 surge protector, like that strip, you're going to see all 12,000 volts, and this is just an average number, to try to knock it down with one device, and it's going to allow as much as 700 volts through. It's still damaging your equipment. This is one of the reasons. There's actually multiple reasons why you want a cascaded system in there. We won't have time today to go into it, but you could have a fault that occurs downstream and come back up, and your surge protection devices, if you put them in cascaded, can actually help you from that as well. But again, just to review on these surge protection devices, you have a type 1 at the main panel, a type 2 at your sub panels, type 3 at your branch circuits, and type 4 at your devices. And by knocking it down lower and lower and lower those surges, you can really help protect your equipment. Plus, it helps in case of faults that occur on a back from a device downstream faulting. It can help protect those upstream devices as well. So the 3 components we utilize to protect ourselves from lightning strikes are: 1, a Franklin-style above-grade lightning protection system that goes on our roofs; 2, a good grounding system below grade to protect us, to dissipate those electrical energies and protect us from some of the other scenarios; and number 3 is a surge protection device to protect us from those other strikes. So let's take our first 4 scenarios. So 1 is an air-to-air strike. So we have this air-to-air strike, goes across from cloud to cloud, causes this gigantic magnetic field to form. How do we protect ourselves from that? Well, our Franklin-style lightning protection system is a Faraday cage, and it helps to protect us from that. Causes our whole building to rise evenly in voltage as that magnetic wave goes across. That copper is diamagnetic. If you recall, we've said this many, many times. Copper is at least 12 to 17 times more conductive than steel in a pure resistance form, 250 to 6,000 times less magnetic or more permeable. And in fact, it's diamagnetic. It helps to collapse magnetic fields. So when that wave goes across, that Franklin-style lightning protection system is doing good work for us. It's making sure that those magnetic fields are collapsing as quickly and is forcing them to form evenly as well. Again, like the bird on the wire, right? It can be at 50,000 volts or whatever the bird, as long as there's no difference in potential. It's only when it touches something else you get a difference in potential does the bird have a problem. Same thing with your building. If we cause the voltages of magnetic fields to rise evenly, we won't have an issue because everything will rise at the same exact time. Now, our second scenario is a direct lightning strike hitting the earth. It goes across like a wave. Well, if we have a ground loop around our building, again, it's going to hit that ground loop, just like we talked about the cows in the fields, right? It's going to hit that ground loop, charging our building evenly and moving across and on its merry way. If we don't have a ground loop and we only have individual ground rods, then that becomes a fault current path for those. So that hits say the wave hits your northeast corner and you just have a simple ground rod on your lightning protection down conductor, it'll go up over your system and down, causing magnetic fields to form inside of your structure. And again, you could suffer damage because you failed to have a ground loop. Frankly, a good lightning protection system always includes a ground loop. Putting individual ground rods is never a complete grounding system, and our code should really honestly reflect that. They currently don't, but they should. So that ground loop protects us from, not only does it protect us from the incoming wave, but it helps to make sure that we stay at even potential at all times. Our third scenario is an incoming power line, right, gets hit and the electricity comes down. Well, that's where our surge protection comes into play. Our surge protection, which is tied to our grounding system, which so it can dissipate those electrical energies quickly and efficiently, comes in, hits our surge protection devices, and protects our equipment, right? And our fourth scenario, again, is a direct strike. The direct strike hits our building. If we have a copper network on top of it, it will protect us, especially if we have a wood structure or a stone structure. It'll help protect that damage from occurring. If it's a steel structure, it helps to reduce the magnetic fields form. If we have a buried ground loop, it helps to protect us because it makes sure that our current distributes evenly as it travels down into our grounding electrode system. Plus that ground, because we have so much current, right? That loop becomes our single biggest grounding electrode. If you recall, and you'd have to go back to our sphere of influence, when you have single ground rods, you're only talking about a sphere of influence. Say you have 4 10-foot ground rods across a 100 by 100 building. Well, that's the sphere of influence. You have 4 20-foot spheres of influence, 10-foot spheres of influence on each of those ground rods. That's it. But if you have a loop, now you have the sphere of influence of 141 feet across that structure because you've got a 100-foot ground loop. You're going to have a much lower resistance to ground, a much better ability to handle and divide and conquer and get rid of that current efficiently and safely. And if you have people leaning or touching against the building, you're also inherently helping to provide a step and touch voltage safety network for personnel that might be leaning on the building during a lightning strike, because now their hand might be at 1,000 volts, but their feet will be energized as well. You'll have to go back to our step and touch voltages to gain that. So in conclusion, we have 4 main lightning risk scenarios, and we have 3 solutions to resolve those 4 scenarios: a Franklin-style lightning protection system, a grounding system with a complete ground loop, and surge protection. And that should protect you from the vast majority, 99%, of all types of lightning damage that could occur to you. Plus, you'll get all the other advantages of having an excellent grounding system that we've talked about in all of our other podcasts. Okay, so thank you for bearing with us through 5 long episodes and all the time it took. And I know maybe we're a little evil on that. Our producers over there laughing at us right now. But we hope it was worth the wait. And hopefully it was very helpful to you. If you're listening to us on one of the podcasts, please make sure you hit the subscribe. Give us a rating. We'd really appreciate it. If you're on YouTube, hit that like button. Leave us a note. We love looking through the comments. Go to our website, esgrounding.com. Leave us a note. Send us an email. Give us a call. We'd love to hear from you. And again, thanks so much for bearing with us. And we'll see you again soon. Thanks a lot. Bye-bye.
Thanks so much for watching. If you found this episode helpful, please give us a quick like down below and subscribe to stay up to date on future educational videos we will be publishing. And feel free to post questions or comments below as well. We might even feature your questions in future videos. If you'd like to learn more about the amazing world of electrical engineering and grounding, be sure to check out our certified online courses at the links in the description below to kickstart your career. See you next time.